in Odessa, Ukraine, and I'm doing a bit of robotics. You see, I've brought some mechanical stuff, some electronics. I have soldering iron with me because something can be broken while you transfer it. I have glue, I have wires, I have a bit of spare parts actually with me here, and a full suitcase of spare parts as well, because everything can go wrong when you try to do some live demos. And as electronics is quite small, I brought this little guy with me. He will be helping me to show you some really small parts like this. So you can see how it works, you can see how it looks, and actually I can turn him around towards me, and we can see some small circuitry that we are doing with kids to teach them programming. Who has kids in the audience? Wow, I have 2 kids, that's why. Who tried to teach kids anything? Not robotics, just anything. Yeah. Do you feel it's easy? No? No one thinks it's easy. That's quite interesting, because I thought that teaching kids is easy initially. So when I didn't have kids, I thought that everything is so easy that and I was so mistaken. So let me introduce myself. I'm Dima. I've traveled from Ukraine and I work for a big corporation, for Oracle Utilities Global Business Unit. Before Oracle, I have worked for Unity Technologies, I have worked for Microsoft, I have worked for Lohika, that's a big Ukrainian outsourcing company, and I have worked for EPAM. So I have a bit of time spent in software development. Who is developing software for living? Yay! So now I'm studying MBA in Kyiv School of Economics. I'm trying to get myself familiar a bit with finances. Who's good with finances here? Well, neither me. I can raise a hand a bit because I think that I know something. And if you're interested in how it looks like, and if you need MBA education, you can just ask me after the session if programmer needs MBA. That's quite an interesting discussion that can take much more than robotics for kids. So, who knows this guy? What's his name? Johnny 5. Yay! I'm a bit confused because young people don't know this guy. And I've been at this movie when I was a kid about 9 times. So I've been after school asking my mom to get to see this movie. It's a short circuit about the robot that had laser on his shoulder. And the robot with laser, I don't know if anything can be more sexy than a big robot with a big laser. So I visited it, I think that they just put it off from the show, but until it was running, I've been constantly going and watching this movie about this big robot. So I'm a bit fan of robots, robotics, and everything that's connected to it. So I do it in my spare time. I try to attract my kids to do robotics as well, but I'm not that successful because you know that kids want to do what? Minecraft. Yeah. They want to do Minecraft. Actually, they want to do whatever is fun. They want to have fun. And if your robots are not fun, then you have no chances because your competitors like Minecraft, like playing like wars with your your super SWAT team fighting terrorists. That's super fun. They have guns, they are running, they are all wet, they sweat, they play, and your robots might be boring. So you have strong competition. If you want to teach kids something, that's not an easy game. So I do often these things by myself. You see, kids are not... I said to my wife that I will teach my kid 3D printing, so I've bought a 3D printing kit. Who has a 3D printer at home? Okay, who has tried to assemble a 3D printer? Okay, never mind. So I tried to assemble a 3D printer. My friend asked me before buying this kit, he said, "Are you sure that you can make it?" I said, "Of course. I haven't made a single 3D printer before, but I was 100% sure that I can assemble it." So do you think I succeeded? I spent 2 months of my personal time. I'm afraid to calculate how many hours I spent sleepless nights doing this, and guess what? I've assembled it. Yay! The question is, do you think it was actually printing? It wasn't. So I've hoped for a miracle that after assembly, printer will start and it will work. So guess what I did? I bought another 3D printer. And guess what happened then? I've realized that ready-made 3D printer also needs some love. And every device that you buy, like printing, like CNC, every machine, every robot, it has lots of moving parts and it needs lots of love, lots of tender, and it actually makes a competition to your wives. And they hate these machines because you play with them, you spend time, you spend sleepless nights with the machines. So it's actually a big competition, not to both kids and wives, so they both hate these machines. So I'm about teaching kids when they don't like machines is a bit hard. So we're trying to print some stuff from Minecraft for kids, trying to print some stuff for the school to make them a bit engaged. But, well, personally, with my own kids, I haven't succeeded with teaching them robotics. But I have some success stories, so it's not about losing the game. It's about winning some portions and losing something, like money onto 3D printers. But you see that I'm trying to assemble a big robot. That's what I have from this. I spent lots of time doing this. That's not an easy challenge. So that's my personal experience. You see that I like tinkering, that I spend some love and tender for the machines. And of course I spend some time and tender with my kids and my wife, because otherwise I would not be there, or I will be there with 2 suitcases full of all my machines. If you break the balance, that's it. So you think that you can teach kids? Are you sure? That's what my initial question was, that what my guess was. I thought that I can teach kids programming, and you know that men, when I was a young boy, I had lots of small toys. When I grew up, now I have lots of bigger toys. And I've created one more toy, that was a school, robotics school for kids. I saw that it's not a challenge, it's easy. You just open school, get the kids, teach them programming, get lots of programmers on the... You see the pattern with 3D printer. It was almost the same. So I just opened programming school for kids. But teaching kids anything is not that easy. Teaching kids is quite challenging, actually, because they want to do what they want, and they don't need your robotics, they don't need writing, they don't need reading, they don't need anything that's hard, because hard is not fun. Have you tried learning something recently? And what do you feel about this? Was there any pain? So I'm trying to teach myself piano. And it's so painful, because every time I press the keys, my fingers ache. And the teacher, what she does, she says, "You're one of the best piano players already, for the time spent with piano." I said, "I spent only 15 minutes. She said, "No one can press the keys like this after 15 minutes. Then she asked me to play some chord. I pressed the chord and she said, "Wow, you're amazing." I said, "I just pressed 3 keys on the keyboard." She said, "But imagine how many people in the world cannot play these 3 keys, this chord. So you are better than 90% of the rest of the world." And you see how she's manipulating me. You see the pattern. Every time I play something, she said, "Wow, you're amazing. Wow, that's you're almost there." But I do realize that I can't even. I was scared of piano in the hall because I know that I can't play. But with her, it's a pleasure. So, do you see the pattern? Small achievements help to beat this gang. Otherwise, they will beat you. And be sure, they're much more persistent than you are, and they know what they want, and they do what they want. So, it's all about, I think, for me, it's all about fun. Because if your teaching is not fun, if your teaching has no achievements, if you have no small candy for each small step, small sugar pieces, then there's no no learning at all. So have you seen Scratch? Yes. Do you know how Scratch programming looks like? Do you know what it's like, Scratch programming? Well, I would like to show you a bit of Scratch programming. So it's an open source project, actually. We are not teaching Scratch itself in the robotics school in Odessa. Why? Because we thought that making it more complex is more fun. So complex things are fun. Don't blame me. That's myself. I like complex things because, like, well, I'm 35 years old, and I can do some things with with complexity. But well, kids don't like that as much. But Scratch is simple. Scratch is fun. Scratch is easy. And we have a code club. Do you know what code club organization is? And there's an hour of code, the event that happens all over the world, and where adults and professionals and non-professional teach kid programming. So Scratch is amazing because kids are creative. It's all like colorful. It makes lots of different, like you can combine controls, music. You can draw anything that you want. So it provides one more, not one more, but two important factors. One is freedom. You can do whatever you want. Even if teacher asks you to do some specific tasks, you have lots of freedom. If you want to play music, you can play music. If you want to draw, you can draw. If you don't want to do anything, you can do, like you can spend just time clicking some images and having fun. So Scratch is fun. And we have an organization in Odessa that provides training to kids by organizing volunteers. So they take professionals like you and they put them, like ask organizations to provide some classrooms, and they put together kids. They do it for free, absolutely. Like rooms are provided for free, kids are provided for free. They are asked to come with laptops, but if they don't have laptops, they try to sort it out. And volunteers, they come just on their own expense, and they do this hour of programming each week with kids just for free, and it's amazing. So we have provided the room where our robotics school was to this organization, to IT school, and my kid actually attended the classes. And I saw the big difference because he likes Scratch programming. When we're trying to assemble something with these Arduinos, he was like this. It's not fun, but when he plays Scratch, he feels excited. You see his face shining. That's something that really surprised me, because the same Scratch that we play with electronics is not exciting for him. But when we add some degree of freedom, he starts shining. He likes it. It's fun. So they make some events where kids can present their works. It's a project-based work, so they complete some small games or some small like movies in Scratch. And it's absolutely exciting when they can come, present, and they feel themselves not just fun, they don't just have fun, but they also feel themselves proud of what they have achieved. They have completed something. And that's something that I really like about Scratch programming. And I wanted to show you a few examples of what he did. It's not serious stuff. Oh.
Hey.
You see why they like it? Because you can do whatever you want. But what was more important, I was preparing for this presentation today, and I've switched, I've just tried to see what's inside, and found out that he copied this dog many times, and each time he had to assemble a code block. So he wasn't lazy, actually, he did it quite persistently. He spent maybe half an hour doing this and debugging this and making sure that each dog rotates the way he wants to. So if you don't know Scratch, then you see it's quite easy. It's just a set of sprites, and you can attach some code blocks to sprites. And it's super easy to get started because this block says when the flag is clicked, start rotating this sprite. And despite that he copied this on each and every dog, it was fun and he was quite proud. He wanted to show us the project that he had created. So now he knows some basic rotation and like what is there. It's loop, repeat, like forever. It's endless loop, and it's rotation movement. So I think that he learned something from doing this project. But what's more important, that he had fun and he has small achievement that's already online, and I can show it to you. So the project that we did together was a bit more complex. It's a fishing game that he has presented. Well, we haven't finished it actually yet. So the shark is quite angry, but the game itself is not that complex, but I will try to make it bigger, if it's possible. It's not, sorry. So the game is not that hard to implement, but what it teaches you lots of things. It teaches you conditions, it teaches you how to create loops, and it teaches you how to make some events, because Scratch is event-driven language. You throw events between sprites, and actually there is like flag clicked is an event, but you can send more events when up key is pressed and it's a separate code block, and they are all independent. So in terms of what can be taught using Scratch, it's quite a lot. So I didn't realize when I've looked at the visual language that has some blocks that it's so powerful and that it can be used for teaching in this way. So it's really amazing. That's something that I haven't used in my school, but it's something that I've learned while looking at my kids studying programming. And they organize some parties for kids, because kids like parties and they like engagement. They want to be part of bigger community, and it's not only for kids, but it's also for volunteers, to keep them both engaged and excited. And there's quite interesting pattern, because doing this for money is not that easy, because your salary is quite high, and using professionals from the industry to teach kids programming is quite expensive. But if you do it on your own expense, if you do this as a volunteer activities, like you invest something in next generation, and you feel, when have you done something for free? Just absolutely for free. Yeah. How do you feel about this? Good? Yeah, it feels like, when someone will ask you, how much does it cost? If you can convert your time to money, how much you have invested? Will you feel better? No? That's an interesting question, because social and commercial, doing stuff for free and doing stuff for money, they're absolutely different. Like, you can't tell your mother that you will pay for Christmas dinner. You can try, but I'm afraid that you won't have any Christmas dinner in any time soon. And like, if your mother asks you if you are hungry, then there's only one correct answer. Yes, I am. If you will tell that I just had a beautiful dinner cooked by my wife, it's on the borderline, because you might have no dinners from your mother for some time. I'm just joking. But doing something for free is important. Making social contributions is important, and not just doing this for money. Doing this for free means that you receive some other sort of reward, and this reward is more important. And putting together these volunteers and kids makes them feel themselves like teachers for just few hours in a week. It doesn't harm their families a lot, it doesn't harm their job a lot, but it makes this restores this balance when everyone from the community has to pay something back, not just with taxes that we all pay, but with labor, with some sort of work that we do. So the school, we called it Fantronica. You can guess that it's a combination of two entities, the most important stuff, fun and electronics. We opened it in a shopping mall, bought all the equipment, all the stuff, and I didn't want to go to Lego on purpose. Do you like Lego? Do you like Lego? Who likes Lego? I love it. 2 hands. I have about 10 kilograms of Lego at home. I think that I will buy more and more and more and more, and Lego will occupy everything. Because it's just fun opening this package and looking at the new pieces of Lego. It's this pleasure is worth a lot of. So, but I didn't want to go with Lego on purpose because I like tinkering. You know, I like glue. I like the smell of soldering. I like to cut something, to use scotch, to use cable ties. You know that you live without cable ties. It's important, impossible. I have cable ties with me there and here and there because like if you have 2 cables or if you have anything, you can fix. This is fixed here with cable ties. They are absolutely amazing. So I bought lots of electronics sensors, and I've been choosing only parts that look like fun. Motors, they are moving. Buttons, they are clicking. Potentiometers, they are sliding. Everything is, if it's interactive, then it's fun. If it's not interactive, like the humidity sensor, it's a bit tough to have fun using humidity sensor. Well, then I have few, but I haven't invested heavily in this. I've invested in some screens to show something there. They have different colors, so they have to be colorful, they have to be fun to deal with, they have to be fun to keep them in your hands. And of course, joysticks. Can you imagine a hardware project without joystick? Yeah. So everything's clicking. Everything's interactive, and that's how we started. So I wanted to teach kids something that's important, tinkering, assembling something, doing some DIY. So you have to do it yourself, not just Lego, but Lego, you will be beaten for gluing Lego or for screwing Lego. Like, you won't be beaten, actually, I don't beat kids, but it's like putting a screw in my heart. If you damage Lego part, it's so painful. I love Lego so much so that we don't use it anyway. But everything else can be screwed, can be cut, can be soldered, can be torn apart and reassembled. So that was the idea, to teach kids not to be afraid, to teach them courage. I said that if you burn anything, like if you break anything, we won't scream on you, we won't ask you to buy something new. We have lots of spare parts, so we will try to fix it, or we will buy a new thing, because courage is the most important thing when you want to teach someone something. If I will tell you, you will have to buy the same thing if you break it. What will you feel? Fear. I don't want to buy this thing. I don't know even where to buy it. And I don't like the tone that you tell me. So you start with fear. And if I tell you, don't be scared, just connect like I show you and everything will be good. If you break something, we won't be punishing you. And do you think that they broke lots of boards in school? No. I was ready to buy it. Like actually I bought a lot of spare parts, but I didn't need them because they have not been spoiling them on purpose. They just like broken few motors, one playing with them, few buttons, that's it, few boards, but we have just disassembled them and had fun disassembling the board. You know that if you have soldering station, what you do? You disassemble everything that you see. So we started with Arduino. Who's familiar with what Arduino is? I am a bit. So Arduino is really now it's simpler. Arduino is simple. It's an USB device. It has a microcontroller here, and it has lots of lines where you can connect the sensor. It has inputs and outputs, and it's quite cheap. You see, this board costs, I don't know, but you can find, it's open source, so you can find some different manufacturers, or you can buy original Arduinos, and they are quite they are hard to break. They are quite sturdy, and they're quite fun, easy to get started with, because to start working with Arduino, you need just a small IDE that's called Arduino IDE. You need the board itself and USB cable. That's it. In 10-15 minutes, maybe in 5 minutes. You can start your first Arduino project, and you will get first response like the blinking LED here. It's super easy to write. That's why when you have kids on the first lesson, they will have something working immediately. Like in the beginning, you show them the board, they spend lots of time connecting the small wires. Probably it's time to show you the wires. They're small. You see my finger? Ah. Oh my God. That's an issue. Now you see it. You see my finger, it's big, it's huge. The wires are small. And connecting wires, you have to close one eye because you have to be sure that you have connected the wire to correct port. You see they're numbered. And you have to make sturdy proper connections and hit the proper contacts to make it work. So that's not quite easy. That's why kids spend about, I don't know, 20 minutes just trying to assemble the wires. And it's not easy. You know that when they have to connect 3 wires, they have to remember where to connect. And for you, it's not easy as well, because you have to check if they have connected these wires properly. And there's quite interesting slide that I've added about complexity. That's how all the tutorials look like. You start from something simple, and then you have to do the rest. Like making robot is simple. You can make a blinking LED, and then you can assemble the rest of the robot. Actually, the tutorial of making InMove is not that simple as well. Some parts involve like assembling, disassembling, watching videos, assembling, disassembling, asking friends for advices, assembling, disassembling. I've disassembled this part about 5 times. I've reprinted a few parts that have been broken during the assembly, but they have video tutorials, they have all the stuff on the website. That's not easy. And writing this example is for kids are already having troubles, not troubles, but it's already complex to assemble this, to make this wire connected. That's why we have switched to making it simple, because like what's complex for kids? Making wires is complex. What else is complex for kids? Have you seen that younger kids are spending time with iPads? They're spending time with phones and iPads. Have you seen them typing something on keyboard? Until they have started playing Minecraft, their typing skills are awful. When I was a kid, the major source of pleasure was a computer, and typing was essential for getting this pleasure, because you had to type the names of the games. If you want to run Mortal Kombat, you have to bring it home on 3.5 inches discs. You have to copy it, you have to unarchive it, you have to launch it if something's broken. You have to have some skills. Now it's just like you go to App Store, you get the application, you press the play button, and that's it. So they are not that skillful as we were when we were kids, because their pleasures now are much simpler and they are easier to get. And when we started introducing them to text programming, we found out that they can't type. Typing is additional degree of complexity. So we've decided to keep it simple. We have to spend some time with kids to let them get familiar with the board itself. So what we did, we used the same Scratch. There is a version of Scratch that is compatible with Arduino. Have you heard about project Scratch for Arduino? That's an amazing project. And I think that we will play with you right now using it's the same Scratch, but what it does, it operates the motors, it operates inputs and outputs, and you can connect hardware to the computer. You can connect this board to the computer in the same 5 minutes. You can get your Scratch program talking to the board. And that's I think that that's amazing. So let me show it to you. Would you like to see how it works? Yeah! I don't have spare USB ports on the MacBook. So I have downloaded Scratch for Arduino. It's I think that it's open source. It's free. You can download it if you want. And I have uploaded a firmware here because Arduino itself is just a board with a microprocessor. It needs a program. So there's a firmware that you have to download and upload to Arduino before you can get started. We will miss this part. I can show it to you later if you want to. Then I connect the board to, and you see, it recognizes the board. So there's, I've uploaded firmware. It's like a microcomputer program that's running there, and it supports some protocol of communicating with this program over USB, over serial. So now it's talking to Arduino. And I have this, this LED. It's connected to power. Two of the wires are connected to power, plus and minus, and one is connected to signal. It's port number 13. Can you see the LED? I can try asking my friend to help me, but I think that it will be a bit tricky. No. So, believe me, it's quite simple. I have here I have lots of controls additional to some of them, like control are, you have seen it with just traditional Scratch, right? I have shown it to you, like cycles, like loops, like conditions, and here I have motion. And in motion I have digital port. And when I click it, it just, you see the LED is shining. Is it shining to you? Okay. So I can switch it off. It's not shining. Shining. Not shining. Already fun, right? You have something, hardware project in just 2 minutes. You can make a blinking LED. That's the first, I think that the first hardware project that everyone does. I will use forever loop. I will combine it with these two guys. And the common mistake that we all do, we don't put this weight at the end. That's, every kid does this because he didn't realize that after switching it, like this operation, switching off and on, is like super fast. And we need another weight condition. I don't know if I can make it larger. No. So when I launch this program, you see it's blinking. It's magic. Wow. And it's all written in Scratch without touching any serious programming. But the programs actually in Flash, in Scratch, can be quite quite complex. But it's not the complexity of having typing code. You can easily manipulate. For example, if I want to react on spacebar on some key, I just drag and drop it here, and I have blinking LED on the press of the button. So we can combine graphical, like you can combine controls from the computer with some movement from the board. Do you think we can do something interesting with this guy? It has servo motors. So let's try. Because motors are they're fun. Actually, what can be funnier, like more entertaining for kid or adult than motors? Are there any things? No, can't imagine. So, well, I don't need this. You know that live demos are a bit tough. I hope that it doesn't remember our last project. So we have a motor control here, and this guy in mauve is connected to the 8th port, to port number 8. The same thing, the servo motor is connected to one of the PWM ports that can be submitted some signal, and The rest is connected to plus and minus. So let's use the motor. Okay, the motor can have the angle. You see, servo motor, you can use some value on this pin, and this value is mapped to a degree from 0 to 180. 180 is huge for this robot. Let's say 100. That's not working with 100. 120. Oh no. 90. Something's working. I can duplicate the block and say 120. So we have some movement. Let me check. We have it can stay on top. Always on top. So we have some robot control. I'm not sure if I can get less than 90 because I'm afraid to break this. Well, he's fast. Now we can add some controls here. We can add keys like space and like, I don't know, something else. What else we have here? Like up, left and right? That's right arrow, that's left arrow. I haven't tried it, so let me check the arrows. Believe me, it's fun. So does it look complex? It isn't, but is it fun? It is. I can do it for the rest of the talk. But I won't because we have more things to do. Thank you, my friend. Okay, now what about the traditional, like when we have passed this part with kids? It's super fun. Like you can assemble everything, and when they get familiar with touching these things and getting response from the board, it's absolutely fantastic. They can do whatever they want, but then they ask, what if we want this thing to be autonomous, like work without this cable? If we want to have something moving, what next? So they ask, if we want to use this thing, how can we attach this? And we say that to do this, you have to type in some code. And that's a huge chasm because it was fun, it was easy. Now you have to type the code, but it's rewarding. You have this LED, and you can draw there. You can write some stuff. We show it to them. We show how it shows beautiful letters, and they're quite excited. So next step is quite hard because for 1 hour they're trying to type. It's not. Have you seen? What was the reaction of your first application, first program that you written in some language? What happened next after you finished your very first program? What you got? Syntax error. That's what I've got when I've been typing on my Commodore. I've been retyping from the book, and I made a syntax error because I didn't know. I had no clue what I'm typing in. That's absolutely normal because that's the first time. Well, initially I thought, you know what? I thought that I will press the button and get it's running. That's all me. But I got syntax error, and it was so like hard because if you get syntax error for the first time in your life, you don't know what to do. That's why we are in the class. We help them to get rid of the first syntax error in their life. And what they can get this their first blinking LED. Like in Arduino, that's how Arduino IDE looks. It's very simple and has lots of built-in examples. So if you want to know how to write your first program, Blink, or how to use any of standard controllers or standard sensors, you will have lots of stuff here, and you have tons of stuff on the internet because everyone's tinkering with Arduino. They have strong community, lots of videos, examples. So I do not understand how you can not get started with Arduino. Like if you have one, you have your hands, you have your eyes, you have a computer and a USB cable, there's no chance to stand against this device. So the first blink look is super easy. Zoom. Somewhere. Well, let's see it in the PowerPoint. That's easier at this point. That's it. So you just assign the LED pin. You set pin mode to output, like you are going to write something there, and you write to this pin, to the certain spin, high value, it's about 5 volt. Then you do delay and write low value, it's about 1 volt, I think. So what's the result? Like, can we compile this? What's your stake? Is it that, will it compile? Yeah. I'm scared. Yeah, it's compiled successfully. Now I will upload it to the board. Live demos are not that easy to do. So we check if the Arduino board is chosen correctly, and we check if the port is set correctly, and we try uploading it once more. And we have S4A running in the background. That means that S4A is using the same serial port, and that happens all the time when I do demos or I teach in school, that this application gives you these weird errors and you don't know what's happening and you are in despair unless you discover that something was running in the background. Please be gentle. Yeah, it's done uploading. And you have blinking LED that's more autonomous. If we connect the battery, it's no longer depends on something running on your laptop. You can just get the battery block, you can connect it to the board, and you will have it running absolutely autonomously 100%, and it would be super fun to do something. What's next? So we've been thinking about this, so we have crossed this chasm. Now it's like we do some small stuff playing with LEDs, and it's quite fun to get started from this point. Because now we can write some autonomous stuff and we can proceed to something more exciting. And what can be more exciting than blinking LED? Your guess? Motors. Yeah, you know my preferences. So typing, I assume that typing is an extra degree of complexity for kids, especially because they want to create stuff, but they having two complex things at the same time when they have to connect wires and they have to type in the code is too much for them. They will not cross this chasm. So we'll help them by removing 1 degree of introducing Scratch that can interact with Arduino. The other thing is that when you have lots of things connected here, you see, it's all not fixed. And when you have lots of wires, it's a bit complex to keep them all together. And when one wire pops up, what happens? Debugging. That's what happens. If one wire is not connected, then you have to find which one. And the first thing that you get, your program compiles, it is successfully uploaded to the Arduino, but it's not working. And then you are checking each connection. And that's additional degree of complexity of hardware projects, because if the program is written correctly, it doesn't give you a guarantee that it will work on the hardware that you have. So we believe that teaching is all about having fun. And that's why we don't give IDEs to kids before they are familiar with hardware and they can debug hardware. That's the hardest part. You have to teach them to check each connection and to make sure that everything is corrected in the proper order and every pin is properly wired. That's the hardest part, and when they have played enough, we can proceed to the motors. So we have created a platform, because having it just connected like this is not fun. Yeah, it's just all the same stuff, but when you have something with motors, it's absolutely amazing. And as we are teaching them to assemble it, we like to tinker. We have assembled it from the plywood and with everything done by ourselves. So we have designed our own forward platform for teaching kids robotics. It's simple. Why plywood? Because you can draw on it, you can put screws on it, you can glue anything to it, you can, and it's quite sturdy. If you have seen these plastic platforms, they are easily broken. But with plywood, it's much more fun to tinker with. So a bit of hardware. You see, I have some preferences here as well. I want it to be quite resilient. Yeah. So it's not easily broken. You can step on it. Well, stepping might be a bad idea, but if you just like if you hit it by something or if you drop it, it has to survive. Otherwise, you will be fixing this platform all the time, all the way in the school. So we've assembled it from what we had available from the radio market, and step by step, it's turning into. You see, you feel, you can smell it. Yes, you can smell the platform, and making platform, soldering, doing this stuff is. It has you put lots of energy inside. That's a fantastic feeling when you have created something. I've taken a few photos. You see gluing, but they, despite making them like tight, they're still unglued. So, and a bit of firmware that's quite important to keep this platform up and running. You see, it's not that hard to make, but what happens after you have taught kids how to type in the code? The next big chasm is what? It's the toughest thing that I've had while teaching myself learning programming. It's function. There were some procedures in BASIC. You had to make go sub, put all the parameters in stack, and then it was so hard for me to understand. That was the toughest part that I've ever met while studying programming. But well, they made it eventually, because otherwise the complexity of this method will grow, and at some point they will still keep it growing. They like methods growing, but debugging them is becoming more and more painful. I know actually one guy who has written a computer game in one JavaScript file. That file was about 90,000 lines of code, and he was absolutely comfortable with it. So he knew this code, but supporting this code is a bit tough. So the next big step for us was teaching them how to make functions, how to operate this. And then it's becoming, so we are constantly, when teaching kids programming, we are constantly fighting complexity, because if complexity creeps in, it's not fun anymore. So we are constantly cutting complexity, otherwise, if it's complex, it's not fun. For them, you introduce complexity by small chunks, and if you are going to introduce complexity, you have to give a huge reward. Like with this platform. Platform is rewarding. Platform is fun. You see? So you can play with it for even longer than you have played with the camera. And if you have few platforms, you can make a battle or you can compete. So once you have this platform up and running and programming this platform, if you see the code, it's not that harder than programming few blinking LEDs, because the commands are the same. You just put up or down signal on the pin, and the driver does the rest of the work. So the driver decreases complexity of the platform, and joystick increases the fun factor. And you can play with platform after the talk. If I would not break it before, but remember it's sturdy. So that's what we try to achieve. We've used these platforms to build, keep them entertained, to keep this thing funny. You can put lights, you can put displays on top, you can fight with these platforms. And the degree of complexity is still not that big, because we are not doing wireless communication. We are just transferring signals over wires, and it's you know that wires are fixed with cable ties. Everything's fixed with cable ties, because if you want to unmount it, you just cut the cable ties and you can reuse the devices. It's much easier to use. So having fun is absolutely a must. These are, we use infrared sensors to power this, to control these things, and that's why they are moving synchronously. They are programmed absolutely identically, and they get the same infrared signal. So tinkering is fine, but if I have restarted the school, I would probably consider using the Node MCU board. Node MCU is compatible with Arduino IDE. It's not compatible with Scratch for Arduino, but it can run some firmware. It has embedded Wi-Fi. It needs fewer batteries, and it's extremely easy to program by using the framework that's called Dmytro. You probably remember this guy. It's quite easy to transfer signal from Dmytro is JavaScript framework. JavaScript is not for kids, I must admit. JavaScript is quite complex, and that's something that still I'm not so sure if it's the proper direction to go, because JavaScript might be a bit too complex. But it's also rewarding, because we can easily make this platform wireless. And if you want to start some project with your kid, and if he's already or she's already more or less comfortable in typing in the code, then with your help, Dmytro would be a huge improvement, because you can use your Wi-Fi router to control your robot, and you can put some camera on top of it, and that would be absolutely amazing toy for a long time. And you can build a small robot using this. You see the Node MCU is mounted on top of this robot. You can build a small two-wheeled robot, and you can actually make this robot fights. Marcus will be making a workshop on Sunday how to build this robot from scratch, and they're absolutely amazing and fun. They use fewer motors, they drive much lesser current, and they're extremely fun to play with. So the guys who are competing here, they are controlling their robots from laptops, from keyboards. That was very fun, and you see that they've managed to customize. They drew faces on them. One was more energetic. They're absolutely identical. The other guy just put lower voltage on the motors for intention. He said my robot should be slower. That's his strong side. So I have two main rules for teaching kids anything. It has to be, everything that you introduce has to be simple enough, and it has to be fun. I have more videos like this. That's how we programmed New Year. That's what you can make. We've been making robot from cup. You put two servo motors, LED inside, and actually with a small paper cup you can do you can have lots of fun, enormous amount of fun. And of course, playing with LEDs in a dark room is something quite interesting. So, are these skills practical? You probably know that everyone who brings your kids to the lessons, they ask if he can do something valuable after the lessons. He's 7 years old, but they expect him to do something practical, something valuable. And it is. If you introduce them to soldering, if you introduce them to connecting the wires, if you introduce them to programming, that definitely puts some skills. So I believe in skills like typing. You at least increase their typing skills by putting a reward like the moving platform. So it is rewarding and it is practical. Now I know it for 100%, but it's not that they cannot be programmers right after at 8 or 9 or 10. But they can do some stuff, like if you give them Scotch, they can probably be, they won't be afraid. So what we give them some basic skills. Like if you can solder 2 wires, that's already good. But next time when they will have to use Scotch or use solder or use whatever they use, they will have courage. They have used it once, they know that it's not scary, they've used it with you, with teacher, and next time they can do it by themselves. And of course you give them inspiration. Is it a good business? I don't know. My experience was not that good. It's a good social project. But in terms of business, it's not that good because you have huge competition, low entrance barrier. If you want to use it as a business, you can ask me after the session. Because the answer to this session, to this question, it depends, and I don't know, but is it fun? It is. Is it rewarding? It is. Do I regret that I've opened and closed the school? And when I'm doing this talk, I'm thinking about opening the school again. So is it rewarding? It is. So if you want to ask questions, I think that we ran out of time and I have a few questions, but if you want to play with hardware or if you want to play with robots or if you want to ask questions, I'm here for the rest of today and for the whole day tomorrow. Find me and I'm open for discussions. And thank you so much.